Okay, so question 1 starts with distance time graph and then moves to velocity time graph. If we look at the question, we're asked to describe the type of motion that the distance time graphs are showing. And we can see that they're both talking about velocity. So either moving at a constant velocity, which means there is a speed, or it's stationary, which means there is no speed or velocity. So if we think about a distance time graph, and we know that speed, or velocity, which is speed in a given direction, is the gradient. So we have a look at the first graph, and we can see that there is a gradient, which means there is a speed. Now, because you have a constant gradient, in other words, it's a straight line, so the value of the gradient isn't changing. Because there is a constant gradient, it means there is a constant speed or velocity. So P is moving at a constant velocity. Now, with Q, we can see that the gradient is 0 because it's a horizontal line, which means that the speed or velocity is 0. If something has no speed, it is stationary. Now, part B is a velocity time graph, and on a velocity time graph, the gradient is the acceleration. And so, with R, again, we have a constant gradient, which means a constant acceleration. So that is R. For S, the gradient isn't constant, it's actually increasing. It's getting steeper, which means the gradient is increasing. If the gradient is increasing, then the acceleration is increasing. Question 2, we have another distance time graph, and the first thing that we're asked is to state the formula linking average speed, distance moved, and time taken. So if you look in your formula booklet, it will say average speed equals distance moved divided by time taken. So you literally just have to copy out word for word what it says in the data booklet. Now, if you want to put symbols, that's fine, but it is really important that you use the correct symbols. If you use the incorrect symbols, whether it's uppercase instead of lowercase or vice versa, you will not get the mark. You need to be very careful with that. So the symbols, if you had done it, we're looking for V equals S divided by lowercase t. Or you could have put S equals VT. Now for B, we're asked to calculate the average speed during the journey. And like for question 1, the average speed is the gradient of the graph, or we could use this formula here. So the average speed, I'm just going to write out the formula, is distance moved or travelled divided by time taken. So we need two things to work this out. We need to know the distance moved during the journey and the time it takes to move that distance. So let's have a look at the graph. The distance moved, we go from 300 kilometres to 700 kilometres. So we've moved from 300 to 700. So to work out the distance moved, I reach 700 and I started at 300. So I'm moving from 300 to 700 kilometres, which is 400 kilometres. The time it takes to do that, it starts at 30 and goes to 60. So the difference in my time is 30 minutes. So to calculate the average speed, it's distance moved, 400 kilometres, divided by 30 minutes. And you have a choice of unit here. So if you want, you can just leave it in kilometres per minute. That's absolutely fine. Or you could have converted. Now, you don't get additional marks for converting, but you just need to make sure that your unit matches kind of the type of number that you've done. So I'm going to leave mine in kilometres per minute, and 400 divided by 30 is about 13. As I say, if you had converted, you would have got alternatives. So it would have been kind of 0.22 kilometres per second or 800 kilometres per hour. It didn't matter. You just need to make sure that if you have converted, the type of number that you've got needs to match your unit. Question 3 is about one of the moons on Jupiter. You don't have to know about the moons of Jupiter, but it just kind of makes the calculations a bit more fun if you have some kind of context. Okay, so we are told that Callisto has a gravitational field strength of 1.2 newtons per kilogram. That's the size of gravity, so that means gravity. That's what we call gravity, but we prefer the term gravitational field strength. And we have an object that has a mass of 37 kilograms. We're asked to calculate the weight. So I'm just going to write down what I know, which is a really good practice. Mass is 37 kilograms. Now the first thing you do is you need to check the units and make sure we're in the units that we want to be. So mass should be in kilograms, gravitational field strength, newtons per kilogram. And now I'm going to find a formula in my formula booklet, and I see that it gives me weight is mass times gravitational field strength. So now I'm trying to find the weight, so I'm just going to substitute in my numbers. So the mass is 37 and gravity is 1.2. If I put that in my calculator, I get about 44. Question 4 moves on to forces. So we're looking at a car which has a driving force from the engine of 6,000 newtons, and there is an opposing force, a force that's working against the driving force, of 2,100 newtons. Now we can see that these numbers aren't equal. If they are not equal, it means there will be an acceleration. Okay? So the car accelerates. That's because the forces are not equal, which means we have a resultant force or a net force. Okay, so it says there's a driving force on the car. That's from the engine. So the person's got their foot on the accelerator, and the engine is providing 6,000 newtons. It says state the name of the other force shown in the diagram. That's this one. So that one is from some sort of opposing force. Now you might have written friction, or you might have written air resistance or drag. So I'm just going to write, air resistance. But you could have written drag, which is a short word for air resistance. Or you could have written friction. Now, because the car is accelerating, there is a resultant force, and we need to work out the size of it for B. It says calculate the unbalanced force on the car. So it's one force minus the other, it's the difference. So I'm going to do 6,000 newtons minus 2,100 is 3,900 newtons. That's the overall resultant force. The mass of the car is 1,200 kilograms. Calculate the acceleration of the car. So we've got a mass. Write down what you know. and we're trying to find acceleration. So I'm looking in my data booklet for a formula in topic 1 which has mass and acceleration in it, and I find resultant force equals mass times acceleration, which means I have the mass, I'm trying to find acceleration, which means I need the resultant force. Well, if I look here, it's this number here. So I'm going to write that there. So I'm going to put force, res for resultant, 3,900 newtons. It's always the resultant force. It's always the unbalanced force. So I have 3,900 newtons equals 1,200 kilograms times A. I'm trying to find A, so I need to isolate A. So I'm going to divide both sides by 1,200. Okay, these cancel, which means that acceleration is 3,900 divided by 1,200, which gives me 3.25. Question 5 is about scalar and vector quantities. So scalar has magnitude only, in other words, a size. Vector is magnitude and direction. So in other words, it can be kind of plus or minus, it could be forwards or backwards, something like that. So it says 3 of the physical quantities are scalar, and we need to draw a circle around the 3 quantities. So these are the ones that can't be plus or minus. Now, an acceleration could be plus or minus. If it's plus, it's accelerating. If it's minus, it normally means decelerating. So it's not that one. A force can be plus or minus. It can be forwards or backwards. So it's not that. And weight is a type of force. So it's not that. Velocity is speed with direction. Now, if it's got direction, it means it's a vector, so it's not that one, which leaves us with speed, distance, and time. B, we're asked to calculate the resultant force and give direction, because it's a vector. So I'm going to work out kind of the size of the opposite, the opposing forces. So I have 5 up and 5 down. So in the up down, I have 5 minus 5 equals 0. In the kind of left right one, I have 8 and I have 2. So I've got 8 to the left and 2 to the right. So if I find the difference between them is 6. So the only resultant force is in the left-right direction, and the value is 6. And we can see that the bigger one is to the left, so the resultant force is to the left. Question 6 is about stopping distances. We're told that the road the car is travelling on... sorry. Okay, and now you've been introduced to my 2 little doggies. Okay, let's try again. So the road the car is travelling on is dry. The driver of the car sees an obstacle in the road and needs to bring the car to a stop. When the driver sees the obstacle, they apply the brakes. Which of these factors affects thinking distance? So thinking distance is the distance covered whilst the driver is thinking about hitting the brakes. Okay? So let's say the driver, sees an obstacle here. They observe, sorry, that's an I. They see the obstacle here. The obstacle is over here. And so let's hope they've stopped. They see it, and the car keeps driving until they hit the brakes, and then it slows down. So here, okay? So they see it, they hit the brakes, and then they slow down to a stop. This bit is called the thinking distances, the distance covered whilst the driver is reacting. After they hit the brakes, we call it the braking distance, and the car slows. Before it hits the brakes, though, there's no change to the velocity. Which factor can affect the thinking distance? So which factor can affect the reaction of the driver? The condition of the tyres is nothing to do with the driver, so it's not that one. Consumption of alcohol by the driver would change their reaction time, so it is B. I'm just going to check C and D. The mass of the vehicle doesn't affect the driver's reactions, nor does the colour of the vehicle. So I'm confident it's B. Which factor affects both thinking distance and braking distance? So that's affecting kind of the driver's ability to react and also the car's ability to slow down. The condition of the brakes doesn't affect the driver, so it's not that. The condition of the tyres doesn't affect the driver's ability to react. The mass of the vehicle doesn't either, but the speed of the vehicle does. And what that means is, whilst the driver is reacting, it covers a certain distance. Now, if the car is moving faster, it will cover a larger distance whilst the driver is reacting. So the distance covered in a certain amount of time would be bigger. So the speed of the vehicle does affect both. The car is moving at a constant speed. The driver of the car sees a hazard in the road and applies the brakes. The thinking distance is 7.1 metres. The braking distance is 8.2 metres. Calculate the stopping distance. So, if this here is the thinking distance, and then we have the braking distance, to calculate the stopping distance, we add them together. So we've got 7.1 metres plus 8.2 metres is 15.3 metres. State the effect of a wet road on the thinking distance and braking distance. Well, thinking distance is all about the driver reacting, and then the braking distance is about the slowing down. So the wet road won't actually affect the driver's ability to react. Okay, so there is no effect. However, the braking distance, it will affect it, because if the road is wet, it will brake less easily. Okay, there'll be less grip, and so it could slide or something like that. So it's actually going to increase the braking distance. Now, because it's a state, you don't need to give a reason why. So you just need to say no effect for thinking distance, and it will increase for the braking distance, because the brakes will find it harder to slow it. Question 7 is an explain. That's like a higher order question, so it's a little bit harder to get the marks. Explain how the graph shows that the lorry has a constant acceleration. Now, we know that the acceleration is the gradient, so that's the first thing I'm going to say. This is worth 2 marks. I need to make the 2 points. So we know that acceleration is the gradient on a VT graph, on a velocity time graph. And in this case, the gradient is constant. So the acceleration is constant because it's a straight line. Now, lots of people that I marked, so from my 3 classes, they got part 2. Very few people got part 1, okay? So just be mindful of that. Very few people that I marked got point 1. Nobody, kind of people very, very rarely said acceleration is the gradient. They didn't actually state that. So just be very careful. For B, we're asked to calculate the acceleration. So calculate the size of the gradient. Now the acceleration is the change in velocity divided by the time taken. So I'm going to work out the change in velocity, which is final minus initial. I'm then going to work out the time taken. So we have a velocity that goes from this number up to this number. Now each one of these little squares is 1, and it might take you a few moments to work that out. So the first thing you need to do is look at the scale and work out the numbers that it actually is. So we go from this velocity to that velocity, and if I just kind of dash this across, you should be able to see a little bit more easily why I've highlighted that. So this number is 5, and this number is 24. So the change in velocity, I'm going up to 24 from 5. So my change in velocity is 19. The time it takes to do that is from 0 to 60. So it's 60 seconds. And I'm just going to check my unit because I'm meters per second squared. So it's meters per second and seconds, so I don't need to do anything with my units. So the acceleration is the change in velocity over the time taken, which is 0.32-ish. You need to have a look at the mark scheme for the actual choice of values that you could have, like the range of values. They allow a range, so just check that. Calculate the distance travelled by the lorry during the 60 seconds. Now, on a velocity time graph, the distance travelled is the area under the line. So I need to find the area under the line, which is all of this. Okay, so to find the area, I need to kind of create a shape out of this, and then it's as if you're in a maths lesson and you need to calculate the area. Now there's 2 ways of doing this. If you're really confident with your area calculations, you could treat it as a trapezium. However, I suspect quite a lot of people would be more comfortable in splitting this into 2 simpler shapes. So if you're not doing it as a trapezium, we can see that this is made out of a rectangle and a triangle. Now the area of a rectangle is base times height, and the area of a triangle is base times height over 2. So if I can find the area of a triangle and the rectangle and then add them together. So let me just write out what I'm doing. So it's the area of the triangle and the area of the rectangle, and then we're going to add them together. Let's take the rectangle first. So the area of this rectangle here, oh, sorry, like that. Okay, now we've got a base of 60. Let me just write out the formula again. Base times height. So a base of 60 and a height of 5. So this is 60, and that's 5. 60 times 5 is 300, and the distance is in meters. The triangle area is base times height divided by 2. So again, the base is 60. And the height is from this point up to this point. So this here is the height, which is 24 minus 5, which is 19. And then we divide by 2. And that calculates as 570. Now the final step is to add them together, which is 870. Question 8, this is the final question. We have a metal ball held at rest at a height of 0.82 meters above the floor. It's released and falls to the floor. So it released and falls. State the name of the acceleration due to free fall. Well, it accelerates due to gravity. So I'm going to write gravity. I'm going to write the proper term though, gravitational field strength. Okay, so the acceleration is gravity. The force, though, is weight. So some people put weight, but weight is a force and gravity is an acceleration. Okay, so weight is a force. So you couldn't put weight. Calculate the speed of the metal ball just before it hits the floor. So I'm trying to find the V, the speed. Let's have a look at what we've got. We've got a distance that it travels is 0.82 meters. I also know the acceleration, and that's gravity, so that's 10. I'm trying to find V, and I've got S and A. If I look in my formula booklet, I have this formula, and this is one of the harder ones. And V, U, A, S. So, I haven't got U, or have I? So, U is the initial speed, and I'm actually told that up here. It's held at rest. So, my initial speed is 0. So if I'm trying to calculate V, V squared equals 0 squared plus 2 times 10 times 0.82. So V squared, if I put that in my calculator, is 16.4. V is the square root of 16.4, which is 4.1. The ball falls for 0.4 seconds before landing on the floor. Sketch a distance time graph to show the motion of the ball as it falls. So it takes 0.4 seconds to land. So my line is going to end here somewhere, okay, on the 0.4. And I look at the distance travelled. Now, let me remind myself the distance it travels. It travels 0.82 meters. So, the distance travelled, I start at 0, and I have to end at 0.82 meters. Now, you can do this by eye, but we're looking for something around there. So we're looking for around 0.82, and that's an eye judgment. And then we need to connect from 0 to 0.82. In order to do that, we need to say, well, what do we want a straight line? So if it was a straight line, it would mean it's a constant speed, but it's not a constant speed because it's accelerating. So acceleration is an increasing gradient. So we were looking for something like that. You could actually exaggerate it a bit. So it was 1 mark to get the correct point there, and another mark for an increasing gradient.